Welcome to the Society of Amateur Radio Astronomers. Detection of Pulsar B1933+16 using the Green Bank 20-meter radio telescope. We start out by looking at the data for the Pulsar using Microsoft Bing or any other search engine. Put in ATNF Pulsar catalog. You'll get this. Click that. You'll go to the Australian Telescope National Facility, which holds the master Pulsar catalog. Now what we're going to do is do a selection. We'll select name, right ascension, declination, period P0, dispersion measure DM, and since we are dealing with the 20-meter telescope which has a 1400 megahertz feed on it, we'll select signal strength for 1400 megahertz. We'll scroll down here, and what we'll do is sort by signal strength at 1400 megahertz in descending order. We'll hit table. Now here's the selection. We got name, right ascension, declination, period P0, dispersion measure, and signal strength at 1400 megahertz in millijanskis. Scroll down until we get to where the data is. You'll see this is 1050 millijanskis, or 1.05 janskis. We'll go down to 1933+16. This is right ascension of 19 hours and 35 minutes. Declination of 16 degrees 16 minutes. Period of 0.3587 seconds. Dispersion measure of 158.521 and 58 millijanskis, signal strength. Now we're going to the SKYNET robotic telescope network, and we're going to add a new observation. We'll put in PSR B1933+16 and do search. And we found that here. Here's where it is on the celestial sphere. We go down here. We see that it's already entered the right ascension and declination. Change the observation name. And then on the visibility, the bottom line is 20 degrees. The recommendation is that you take the observation when the elevation of the object is above 20. This here is at 45 right now. So we'll save and continue. We are doing a pulsar. Pulsars using this system is in low resolution mode. We have a selection here of the filters, hydrogen, all the way to everything, the full bandwidth. We're going to use the full bandwidth. It gives us more chances of seeing the pulsar. We're going to save and continue. We're going to use track. Our options are map, daisy, and on-off. Track will hold aim at the pulsar during the entire length of time. We'll use 60 seconds and 0.001 integration time in seconds. So now we have our inputs to the observation. And we'll go ahead and submit. We'll see the status of our observation. We've skipped ahead a little. Here's our observation. It's completed. Click on that. We'll hit one more button, and there's our observation. This is the time versus phase. We see as you got a strong signal all the way up through the entire time. This is two samples of the same pulse. So that looks very normal. The high peak and the low signal strength on the rest of it shows it's a very strong pulsar. You got a very good indication of a pulsar here. Chi-square is another indication. You got a nice clean linear line here going up. On this plot here, phase versus frequency, you see that the frequency across this bandwidth here had very strong at first, up to a certain frequency, had a big gap, and then a little lighter at a higher frequency. You could use this later to maybe just take frequencies between here and here, and it might give you a cleaner signal. The dispersion measure is here. You really can't read that at that point, but you can come up to this measure here. The dispersion measure measured is 157.638. That's a little lower than the recorded in the ATNF database. It's pretty close. Down on these plots here, this is your P dot, which is the derivative of the period. Here's your period. It came in at 358.72 milliseconds, 0.3587 seconds, which is right with the database. And if you plot these two with period on the bottom and P dot on the side, you get a nice point, which is a very firm estimate of a good pulsar. Thank you for joining us for our detection of pulsar B1933+16. If you're interested in radio astronomy, please visit our website at radio-astronomy.org. Thank you.